it's Sabino. Today, I'm going to show you one of the first things I ever learned in physics, which is the principle of moments. A famous mathematician, Archimedes, once said, "Give me a lever and I can move the world." And in reality, it's impossible. We know that, of course. Theoretically, though, given the right circumstances, he could. So, before we move on to moments, I want you to consider two items that almost have a daily use: seesaws and scales. What we have in front of me is basically that, and we can edit its use to be one or the other. Here I've got some weights. So these are 5-gram weights. This is a 10-gram weight. And this is a 20-gram weight. These are all the weights we'll be using today. Now, if I was using a scale and I placed one end there, the scale would be heavier than the other side. In order to balance it, I'd have to use a similar weight on the other side. Okay, so with two identical weights on either end, the scale is balanced. Now, what if we don't have even weights though? That's normally what happens with a seesaw. If you go to the playground with, say, a friend or a child, your odds are you don't weigh the same amount. And so that's what results in, going up and down, because the heavier person's mass pulls them to the ground, puts the other person up. Then when they push back up, the lighter person's pushed down and they're up there. And then gravity does the rest of the work. Let's say I went to the park and, well, I'll be the heavier weight. And let's say I went with my cousin Ines, who's the lighter weight. If we were on the seesaw and for some weird reason, decided rather than try to go up and down on it, we want to remain completely level, what we have to do? Well, this is the principle of moments. The principle of moments says that the downwards force of an object on a pivot is equal to the weight of the object times the distance from the pivot. So, in order for us to remain in equilibrium, our forces would have to be equal. Meaning, say, if I was halfway along my side of the seesaw, which is about, let's call that 10 centimeters from the pivot point, Ines, who's about half my weight, would have to be twice as far away. Let's see, look, the system is in balance despite me using two differently weighted objects. All that matters is that the heavier object is closer to the pivot than the lighter object is. Bringing this back to Archimedes, he could theoretically move the Earth if the Earth was say, as close to the pivot point as possible, and he was on the end of another almost infinitely long side of the lever. If he's still on one end, his force would be great enough that he would actually tip the Earth and thus lift it. These things have numerous uses. In fact, since in the Middle Ages, this was the basis for catapults and other siege engines. And today they're used in automobiles, construction sites. Your own body even has a function like this in your arms, where this is your pivot point and these are the different sides. Well, I hope you've learned something today, and feel free to check the other videos out on our site. Thank you.